Hello again. So in this video we're going to look at how we find the equation of a straight line. Now the equation of a straight line is also known as y equals mx plus c, where y and x are coordinates, m is the gradient, that's the steepness of the line, and the c is where the line cuts the y-axis, that's known as the y-intercept. So if we look at this red line first of all, if we're looking to find the equation of a straight line on a graph like this, we want to find the value of m and the value of c. And if we have the value of m and the value of c, we have the equation of that straight line. Well, the value of m, the gradient, is known as the change in y over the change in x. So if we look at this red line, we can pick any point on the coordinates. So I could pick this coordinate here, and I could go and pick another coordinate, and then I could look at the change in y and the change in x. If I just draw a triangle here, the change in y here is 3 minus 1, which is 2, and the change in x here is 1 minus 1, which is also 2. So now we've got the change in y is 2 and the change in x is 2. So in this case, we have got 2 divided by 2, which is 1. So for this equation here, we can say that our value of m is equal to 1. Now looking at the red line still, the value of c is where the red line cuts the y-axis. That's known as the y-intercept. That is here. So you can see the line crosses the y-axis at a positive 2. So we can see that c is equal to a positive 2. So now for the red line, y is equal to, well, we've got 1x. We don't say 1, we just say x plus 2. And that is the equation of that line. Now if we look at this blue line, we can do the same thing. Let's find the value of m. So I'm going to go across and I'm going to go up just at two obvious points that I can see. So this coordinate here is minus 2, and this coordinate here is minus 3, minus 3. Change in y is 1, change in x is 1. 1 divided by 1 is also 1. So the value of m for this line is 1. So I have y equals 1x, we just say x. But this time, the line cuts the y-axis at 0. So we're not going to put plus 0, we just leave it as y is equal to x. And what that means is every value of x has a value of y that's the same. So let's look at that. We have got minus 3, minus 3. This coordinate here, minus 2, minus 2. This coordinate, minus 1, minus 1. 0, 0, 1, 1, 2, 2, 3, 3, and so on. Now I'm hoping by now you've noticed something about these three lines. I'm hoping you recognise that they're parallel. Parallel lines have the same gradient. So I know the gradient of the red line and the blue line is 1. Therefore, the green line is also 1. I can say that is y is equal to 1x. This time it cuts the y-axis at minus 2. So it's y equals x minus 2. They are the equations of these lines. So the key thing to remember here is that y is equal to mx plus c. Y is equal to the gradient multiplied by x plus the y-intercept. All right, let's move this forward. So we're looking at two lines. Again, they look parallel to me. So we're looking to find the equations of both lines. The key thing here is to remember the equation of a line is y is equal to mx plus c. So we're going to find the red line first. So we know that is y is equal to something multiplied by x. Well, that's the gradient is m. So again, pick a coordinate that you can use. So I'm going to use minus 2, 0. And I'm going to go up to here because that's on an obvious point. That is minus 1, 2. Again, I can draw my triangle. The change in y is 1, 2. The change in x is 1. So the value of m for this is the change in y divided by the change in x, and that is just 2. So now y is equal to 2x plus the value of c. Well, the line crosses the y-axis at 4, so the y-intercept is 4. That is plus 4. Thinking back to these lines, we said that parallel lines have the same gradient. Moving forward, if these are parallel, the gradient for the blue line would also be 2, but we'll check it. So here goes. I will just pick these points here. The change in y is 2, the change in x is 1, 2 over 1 is 2. Yes, it's still the same. So yes, it's y equals 2x. This time though, the y-intercept is at minus 2. So there we go, it's just minus 2. So they are the equations of those two straight lines. Again, the key thing is to remember that formula, to remember that m is the gradient, and the gradient is the change in y divided by the change in x, and that c is the y-intercept. That's the position where the line crosses the y-axis. Okay, another step forward. So we've got two very different lines here, but the principle's the same. We start off with the formula y equals mx plus c. This is always the formula for a straight line graph, or a linear graph as it's also known. So if we look at this, we can draw a triangle. Again, we can pick a number of points. I can see there's an obvious coordinate here. I can go across, and actually it doesn't matter whether I make it bigger or smaller as long as I go to a coordinate that I can pick out. So the change in y is the difference between 4 and 0, which is 4. The change in x is the difference between 1 and minus 1, which is 2. Gradient is the change in y over the change in x, and that is just 2. So for this line here, y is equal to 2x. Well, hold on a minute. That can't be 2x, because if we go back a second, this was 2x and 2x was going in this way. So there's something I've got to be careful of here. Let's go forward again. My line's going down. So this is not a positive gradient. This is where I've got to be really careful here. You've really got to think about your directions. So if I am starting here and I am going this way to the right, I get a positive. If I started here and went to the left, I would get a negative. So that's a positive 2. I'm at this point and I'm going down here. Now, if it was going up, it would be a positive, but because it's going down, it's a negative. So that's not a positive 4, that is a negative 4, and we need to be very careful of that. So I will change this. We now have minus 4 over 2, and that is minus 2. That's what I should have. So my gradient is minus 2. So now this line here is y equals minus 2x. And all we need to do now is find the y-intercept. Well, that is just there. That is positive 2. So you've got y equals minus 2x plus 2. Just be careful, because sometimes that can be written as y is equal to 2 minus 2x. It is exactly the same thing. Looking at the blue line now, we're still using this principle here. So I've got a coordinate here I can use and a coordinate here I can use. So again, I'm looking at the changes. Well, the change in x is from minus 4 to 0. If I'm going from here, going to the right, that's a positive. So that's 4. I'm now here. It's going down by 1, so it's negative 1. So in this case, m is equal to the change in y divided by the change in x. So I've got a minus a quarter here. And all we do is we show that exactly as it is. Y is equal to minus 1 quarter x plus c, and c crosses at minus 3. So I don't put plus minus 3, I just put minus 3. And they are the equations of those two lines. So the key thing here is to recognize that you can have fractions, you can have negatives. Notice if I go back a few steps, a positive gradient goes up from the left to the right, up from the left to the right, and a negative gradient goes down from the left to the right, goes down from the left to the right. Okay, now we're looking at perpendicular lines here. I'm not going to work out the equations of these lines, but I do want to show you something here. Again, we just remember that m is the gradient. So I'm going to work out the gradients of both of these lines. So we've got the gradient of the red line. Well, the gradient of the red line, I could do it from here. Well, that's 2. Again, going up, it's positive. That's 1. So the change in y divided by the change in x, 2 over 1 is just 2. So the gradient for the red line is 2. Looking at the blue line, goes 2 to the right, going 1 down. So don't forget that's a negative 1 there. So the gradient for the blue line is minus 1 over 2. Now, a question could say, are these two lines perpendicular? Or show that these two lines are perpendicular. Now, to show that they're actually 90 degrees to each other, or they intercept at 90 degrees, what we can do here is we can multiply the gradient of the red line, so m1, by the gradient of the blue line, m2. Now, when you do that, if the product of both of those is equal to minus 1, then they are perpendicular. Let's just check that with these two. So m1 is 2. We're going to multiply that by minus a half. 2 times minus 1 is minus 2. We've got invisible denominator of 1 here, so 1 times 2 is 2. 2 divided by 2 is 1, and we're left with minus 1. So they are perpendicular. The key message here is the product of the gradients of perpendicular lines is equal to minus 1. Best to remember that one. Okay, to summarise, y and x are just coordinates. M is the gradient, and the gradient is the change in the height, or the change in y divided by the change in x. And the c is called the y-intercept. And all that means is it's where the line crosses the y-axis. As always, if you've got something from that, please like and subscribe.